The Universe by Marcia K. Miller. What is Earth's place in the universe? The universe. Astronomy is the study of space and the objects in it. It is one of the oldest sciences. We know that people have been studying the sky as far back as 3500 BC. Early astronomers could see only small dots of light above them. In 1609, the scientist Galileo was the first person to use a telescope to look at the sky. What he found changed the way people think about space. Scientists today use very powerful telescopes to look into the sky. We're not sure how far in any direction the universe goes, but each year, scientists can see deeper and deeper into space. They study the energy, matter, and empty space that make up the universe. Earth is part of the Milky Way galaxy. A galaxy is a huge grouping of stars. The universe is made up of clusters of billions of galaxies. Each galaxy has billions of stars. You can see part of the Milky Way galaxy in the night sky. It looks like a pale white stripe or band across the sky. If you were far away from the Milky Way, you would see that it forms a flat pinwheel. Our Sun is one of the stars in the Milky Way. It is located in one of the arms of the pinwheel. Our Sun looks brighter and bigger than other stars because it is much closer to Earth. There are 3 types of galaxies. The Milky Way is a spiral galaxy. Elliptical galaxies are shaped like an ellipse or oval. Irregular galaxies have no regular shape at all. The planets. The Sun and the bodies around it make up our solar system. Earth and 8 other planets orbit the Sun in our solar system. All the planets have orbits that look almost circular, except for Pluto, which has a more elliptical orbit. The Sun's gravity holds all of the planets in their orbits. A moon is a natural body that orbits a planet. Most planets have 1 or more moons. Only Mercury and Venus have none. Asteroids are small bodies made of rock and metal. Over 100,000 of them orbit the Sun. Comets orbit the Sun as well. They are small bodies of ice which orbit in long, narrow ellipses. A comet may pass close to the Sun in part of its orbit, which causes the comet to heat up. Then, it forms a stream of gas and dust that trails it as it moves through space. The far end of a comet's orbit is deep in space. Objects in our solar system are very far apart. Scientists use a special unit to measure these great distances. It is called an astronomical unit. An astronomical unit is the average distance Earth is from the Sun. 1 AU is equal to 149.6 million kilometers. The inner planets: Mercury, Venus, Earth, Mars. The outer planets: Jupiter, Saturn, Uranus, Neptune, Pluto. A model of the solar system. The model here shows how the planets are arranged, but it cannot show the relative distances between them. The solar system covers a huge distance. It is impossible to make a scale drawing of it on regular paper. Look at the table on the next page. The small units of measure help you to understand how the planets compare in size and distance. By this model, Earth is 1 millimeter in diameter. This is very small. Even at this small size, it needs to be 11.7 meters from a model of the Sun. Now you can see why it is impossible to show the planets to scale in a book. This is true even when we shrink Earth to such a small size. Why planets differ. A planet's distance from the Sun is not the only way in which planets differ. It is true that a planet nearer the Sun gets more sunlight than a planet that is farther away. Mars is about twice as far from the Sun as Venus. And this is one reason that Venus is warmer than Mars. But this is only one factor. Venus, Earth, and Mars were similar when they formed billions of years ago, but each has changed over time. A planet's size affects how strong its gravity is. Larger planets have stronger forces of gravity than smaller ones. Stronger gravity holds more gases near to the planet, forming a thicker atmosphere. Mars has less gravity than either Venus or Earth, so its atmosphere is very thin. It holds in less heat, making Mars very cold. Mercury, rocky with craters, extreme temperatures, traces of hydrogen and helium in atmosphere. Venus, mostly rock with craters. Atmosphere of carbon dioxide and sulfuric acid keeps it very hot. Earth, mostly water-covered. Only known planet with an atmosphere to support life. Mars, covered with red dust, white polar caps, craters in southern part. Atmosphere mostly carbon dioxide. Jupiter, covered by liquid hydrogen, very cold. Atmosphere mostly hydrogen with clouds of ammonia crystals. People once thought that Venus might be very similar to Earth. Both planets are about the same size and mass. Scientists have learned, however, that temperatures on Venus can get as high as 475 degrees Celsius. Its atmospheric pressure is about 100 times that of Earth. Venus is very different from Earth because the thick clouds that cover Venus are made mostly of carbon dioxide. This gas traps and holds in heat, making Venus much hotter than Earth. Saturn, core of rock and iron surrounded by ice and liquid hydrogen. Very cold. Strong winds and swirling clouds of ammonia in atmosphere. Uranus, composed mostly of hydrogen and helium gases. Very cold. Appears green. Neptune, possibly covered by liquid hydrogen and helium. Mostly hydrogen and helium gas in atmosphere. Appears pale blue. Pluto, frozen methane and ice. Small amounts of methane gas. Ice cap at North Pole. What do we know about stars? What stars are? A star is a huge, hot, glowing ball of gas. Stars shine because they produce huge amounts of energy. There is great heat and pressure in the center of a star. This causes the atoms there to bump into each other at very fast speeds. When this happens, the nuclei of two or more atoms join or fuse into one larger nucleus. This process is called nuclear fusion. In this type of fusion, hydrogen nuclei form helium. This gives off huge amounts of energy as radiation. We can see some of this energy as light. Distances of stars. Distances in space are too large to describe in units such as kilometers. Even the astronomical unit is too small to use. Scientists measure distances in space using light years. A light year is how far light can travel in 1 year. This is a distance of 9,460,000,000,000 kilometers. At that speed, light can circle Earth 7 times in just 1 second. The Sun is the closest star to Earth. The next closest star is Proxima Centauri. It is 4.3 light years away. Suppose that this star blew up tonight. You would have to wait more than 4 years to see the flash. Other galaxies and their stars are millions of light years away. The light you see from them was given off millions of years ago. Star brightness. Some stars appear bright because they are much closer than other stars. However, there are other reasons why stars vary in brightness. Scientists use the term magnitude to describe a star's brightness. The brightness we see from Earth is called apparent magnitude. The brightest star we see is our Sun. It has the greatest apparent magnitude. No other star looks brighter to us. Absolute magnitude measures how bright stars would look if they were all exactly the same distance from Earth. Some stars are as much as 156,250 times brighter than the Sun. Star color. Stars appear in different colors. Some stars appear blue, while others seem white or yellow, and a few look red. Star color depends on surface temperature. Think about heating a steel bar. At first, it glows red. As it gets hotter, its color changes to orange, yellow, white, and then blue. Stars get their color in the same way. The hottest stars are blue, and the coolest stars are red. The chart below relates star color to star temperature. Star life cycle. Stars shine for billions of years, but they do not shine forever. Like living things, stars change as they age, and eventually they die. A star changes in the size, color, and brightness as it goes through its life cycle. A star begins in a nebula. This is a huge cloud of hydrogen and other gases. Gravity pulls these gas particles together. A clump of gases is formed. The clump heats up as it pulls in more particles. Nuclear fusion begins when the star's core reaches 10 million degrees Celsius. Energy made by fusion heats gases, which then push out as gravity pulls in. When the push of gases becomes greater than the pull of gravity, fusion energy reaches the surface and a star is born. Many stars are paired with a partner star. If one star is a white dwarf, its gravity attracts gases from its partner. If enough gases collect around the dwarf, it may explode. It shines so brightly that from Earth it looks like a new star. This is called a nova, from the Latin word for new. A white dwarf has a hot, dense, compact core. It is what is left behind after a red giant gradually loses its outer gaseous layers. A black dwarf is a dead star. It is still a compact, dense body, but because it has used up all its fuel, it does not shine. A small or mid-sized star, such as our Sun, glows yellow for about 10 billion years. A red giant forms when nuclear fusion slows after a star has used up most of its hydrogen. The outward force of fusion no longer balances the inward pull of gravity. The star begins to collapse. Heat and pressure cause helium atoms to fuse into heavier atoms. The outer layers of the star expand, cool, and turn red. A nebula is a huge cloud of gases that forms in space. A massive star is 10 to 30 times bigger than our Sun. It glows blue for about 1 million to 20 million years, which is most of its life. A supergiant is like a red giant, but much bigger. Nuclear fusion in its core creates heavier elements, such as iron. The outer layers expand a lot, becoming cooler and redder. Gravity pulls the outer parts of a supergiant toward its center. Pressure and temperature build until the star explodes, producing a supernova. What is left of the star becomes a neutron star, or rarely, a black hole. Constellations. Have you heard of Gemini, Orion, or Leo? The ancient Greeks first gave these names to groups of stars. They named a total of 48 star groups. The Greeks linked the star patterns with their myths and gods. One example is the story of Orion, the hunter. He fell in love with the goddess Artemis, who placed Orion in the night sky after killing him by accident. Scientists today divide the sky into 88 star groups called constellations. Every star is part of a constellation, but stars in the same constellation may not be related in any other way. Ursa Major means Big Bear. It is one of the best-known constellations. The Big Dipper is part of Ursa Major. The two stars at the end of the bowl of the Big Dipper always point to the North Star, which is always over the North Pole. Constellation movement. Do you watch the stars? If so, then you know that patterns in the night sky change from hour to hour. A starry sky looks different in the early evening than it does in the early morning. Star patterns also change with the seasons. In the northern hemisphere, we see Orion high in the winter sky. But in summer, we lose part or all of Orion as it dips below the horizon. Changes like these should not surprise you. You know that the sun appears to move across the sky during the day. Stars appear to move in the night sky. Both changes are actually due to the movements of Earth. Earth rotates on its axis as it orbits the sun. These movements affect the star patterns we see.